Hello everyone, welcome to Gogetmyguru. In this session, let's discuss about Python Bitwise Operator. So let's first understand what is the meaning of Bitwise Operator. As the name itself suggests, bitwise, that means operation is performed bit by bit. So there are 6 bitwise operators in Python. Let's see what are they. Bitwise AND, Bitwise NOT, Bitwise OR, Bitwise XOR and Bitwise Leftshift and Bitwise rightshift. So these are the 6 bitwise operators available in Python. Let's understand each one of these bitwise operations in detail. So first we'll discuss bitwise AND operator. So how this works? Suppose you have 2 variables, that is A and B, and this is called the truth table. Whenever you are doing AND operation, if both the bits are 1, then only you will get 1 as output, or else 0 will be your output. So this is how bitwise AND operation is performed. Let's write a piece of code in VS Code and understand exactly how this works. So first we'll take a simple example of A and B as variables. So A is equal to, I'll give value as 15 to this, and B is equal to, I'll give value as 14 to this. Now we'll perform AND operation on these 2 variables. Then we'll print the result, print A and B. So what should be our output? First let's run and check. Then I'll tell you. You can see that the output has come 14. So why is it 14 now? Let's go back to code. Whenever you are doing bitwise operations on integer, first the integers are converted to binary numbers and then bitwise operation is performed. So here binary value of 15 is 1111 and binary value of 14 is 1110. So here itself you can see 1, 0, it becomes 0 and rest of the values will be 1 because all these bits are 1. So we saw the truth table, that is whenever both the bits are 1 in AND operation, then only we'll get 1 as our output, or else the output will be 0. So the resultant result what we have got here is, we'll print the result also in binary format. So let's make use of binary function and then use this AND operator. Now let's run this. Here you can see that this is the decimal value of result, that is 14. Binary equivalent of this decimal is 1110. I hope you are clear with this AND operation. Now that we know how this AND operation is performed, any guesses where exactly it can be used in programming? Of course, you can toggle the bits using this AND operation. Apart from that, any guesses? So consider bitwise AND use case. We have to check whether the number is even or odd. So every one of us know we can divide it by 2 and tell it as even. If it is not dividing by 2, then it is odd number. So now I will show you how we can make use of this AND operation to do the same functionality. So I will define a simple function here. That function checks whether the number is even or odd. I'll pass a parameter as n here. Now I'll make use of if condition to check whether the given value n is even or odd. So I'll make use of AND operation here. If n and 1 is equal to 1, then I have to print this, the number is odd, else print the number is even. So this is the functionality our function is doing. Now we'll take the input from user. For that I'll assign one variable and take input, enter the number. Now it's time to call this even or odd function. So even underscore odd. With what we have to call? With the value we have to call. So let's run this and check whether it works. Let's run this and check. So here it is asking us to enter a number. I'll enter 73. So this 73 is odd number. I have to get result as odd. Here you can observe that the number is odd. So we have implemented the same functionality to check whether given number is even or odd with Bitwise AND operator. So let's move on to next topic. Next, second topic we'll discuss is Bitwise OR operator. So observe this truth table. Here, if both the bits of A and B are 0, 0, then only our output is 0. For all other combinations, output is 1. Let's understand with an example. So observe here, we'll make change in this code itself and we'll take the same values. So instead of this AND operation, I'll give now OR operation here, and I'll also print the binary value of this OR operation. So let's run this first. So what should be our output? Any guesses? Guess from here itself. So whenever both the bits were 0, our output was 0, or else it was 1. So here you can observe that in A and B, we don't have both the bits as 0. So our output will be 1, 1, 1, 1. That is 15. Let's run and check that. Here you can observe we have got the correct result. That is the value, decimal value is 15 and its equivalent binary is 1111. Now that we know how this OR operation works, any guesses how it can be implemented in programming? Try to guess. Okay, let me tell you. So let us consider a use case for this Bitwise OR operator. So what you are observing here? This is a 7-segment display. So this 7-segment display, each alphabet is treated as a single bit. So assume that now it is not on. That is, all the bits are 0. I want to display a value 3 to this. So how I can do that? For that, I need to set bits A, B, G, C and D. So whatever I have marked here, I have to set these bits. So what will be my binary value for setting this? Let's understand that. So A is 1, B should be 1 and my C should be 1, D should be 1, E is 0, F is 0, G is 1. So these are the bits you need to enable in order to display 3 on this 7-segment display. So what is the decimal equivalent of this number, binary number? Decimal equivalent of this binary number is 121. So let's write a code and understand. Initially all the bits are 0. So I'll take LED underscore status is equal to all the bits are 0. Since it is a 7-segment display, there will be 7 bits, 7, and we have to mask this now. So I'll take a variable mask. So what value we have to write there? So we have got binary value. So this is equivalent of 121 in decimal. So I have shown you how did we get this mask value. Now let's print this LED status and then mask. So let's run this. Here you can check that we have got the same mask value. So whenever you want to set a particular bit or enable a particular bit, you can go for this OR operation. I hope you are clear. So next let us discuss about Bitwise XOR operator. I hope all of you know XOR operation. What is XOR operation? Suppose we have two variables as A and B. So A XOR B will be A bar B plus B bar A. So this is XOR operation. You can see here 0, 0. So that means A will be 0 and here A is 0 means A bar will be 1 and B will be 0 plus B bar. B is 0 means B bar is 1 and A is 0 means it will again will be 0. So 1 into 0 is 0 plus 1 into 0 is again 0. So our output will be 0. I hope you are clear. So how we are getting this table? So this is the formula to calculate XOR operation. Now let's write a piece of code to understand this. we'll take the same values as 15 and 14. So we'll just modify the symbol here. Let's run this and check what output we will get. So here you can observe that we are getting 1 as the output. So the decimal value is 1. Or you can see here that from bit number 1 to 3 we are having same values in A and B. That's why it will be converted to 0, and your LSB bit, that is first 0th bit, will be 1 because we are having two different values here, that is 1 and 0. 1 XOR 0 is 1, 1 XOR 1 is 0. I hope you are clear now how we got this output as 1. So consider a use case for XOR operator. So you can observe here we have two switches. So when this bulb will be on according to XOR operator? When we have two different bits for these two switches. So when this bulb will be switched on, this bulb will be switched on only when one button should be on and the other button should be off. So let's implement this logic using XOR operator. So we have two switches. Let's define switch 1 as SW1, and this switch 1 input will take from user. So input, enter the input for switch 1. So let's take switch 2 input also from user. Input, enter the input for switch 2. So now we'll make use of XOR operator. If switch 1 XOR switch 2 is equal to 1, we have to switch on the bulb. So print switch on the bulb, else print switch off the bulb. So depending on the switch condition, we are going to print these two messages. So here we have to take integer because we are comparing it with the integer value. So int, let's run. Here it is asking us to enter the input for switch 1. I'll enter switch 1 as 1 and enter the input for switch 2. Suppose switch 2 is off, I'll enter it as 0. So here you can see that switch on the bulb. We are getting switch on the bulb. Why? Because when I perform 1 XOR with 0, my output will be 1 itself. So 1 means switch on the bulb. Now let's give a different condition. Enter the input for switch 1. I'll give 1. And enter the input for switch 2. I'll give 1 again. Now you can see that switch off the bulb. So 1 XOR with 1, it is giving 0. So 0 means switch off the bulb. I hope you understood the logic behind this. Next, let us understand Bitwise NOT operator. So Bitwise NOT operator is nothing but the reverse of the input. Suppose we have 0 as input bit, the output will be 1. That is the reverse of this. You can call it as negation or tilde operator as well. So if it is 1, it is converted to 0. Let's take a variable a. Let's take a value as 6. Now I'll make use of NOT operator here. Print NOT of a. So let's check what will be printed. You can see here that it is printing 7. Then how this minus 7 will be stored in the computer? Let's observe that. So in the program, we have given value for a as 6. So what is the binary equivalent of 6? Binary equivalent of 6 is, let's take 8 bits, the binary equivalent of 6. So when I did a NOT operator on this binary, we have got a value as minus 7. Then how that minus 7 will be stored inside a computer? So we'll take 7. So we have got 7. So what will be the value of binary equivalent of 7? Binary equivalent of 7 is, so this will be the representation of 7. So 7 is again ones complemented. So what will be the ones complement value? Ones complement is nothing but just reverse 0 to 1 and 1s to 0. So now we have to do 2's complement for this. So we have to add 1 to this 1's complement to get 2's complement. I hope all of you know that. So when I add 1 to this, what will be my output? So always negative values are stored using 2's complement. So what is this left shift? Suppose I have a value as 20. I want to do left shift operation on this decimal value 20. So the binary, it is first converted to binary. So the binary equivalent of 20 is this, and then now let's use left shift operator. That means shifting will be done left side. So 0th bit will be transferred to position 1. First bit will be transferred to position 2. In that way, the left shift operation happens. You can see here that 0th bit is moved to first bit is moved to second bit, then this bit is empty. So what we'll write in this bit? So this bit we will write it as 0. Now the equivalent value of 20, when I shifted left by one position, I got it as 40. So what does this denote? Into 2 I am doing. Did you get? 20 into 2 becomes your 40. So this you can make use in multiplication operations. Now let's discuss bitwise right shift operator. So how right shift operator works? It is the reverse of left shift operators. Let's take a same decimal number here. So this is the binary equivalent of decimal number. Now when I do one position right shift to this decimal value 20, that is, here you can note that we are shifting right. So this is the value I get. This, because the MSB bit is shifted to the next bit, this bit becomes empty. So we'll append a 0 here. So what is the decimal equivalent of this value? So decimal equivalent of this value is 10. That means when you are doing a left shift operator, you are multiplying it with 2, and when you are doing a right shift operator, you are doing a division operator. So you can make use of these bitwise operators for multiplication and division operation as well. So let's understand these two left shift and right shift operations in code in programming. So let's take the same value what we have seen in the example. So I'll say A is equal to 20, and I'll print this A left shift by one position, as well as print this A right shift by one position. Let's run this. So you can observe here that we have got 40 and 10. So 20 has become 40 when I did left shift, and 20 has become 10 when I did right shift operation. I hope all of you are clear with all the concepts we have discussed today. If you like our videos to support us, leave us a feedback in the comment section. Have you subscribed to our channel? If not, request you to click on subscribe button and hit the bell icon to receive regular updates. Thanks for watching. We'll see you again in the next session. Keep coding. Happy learning.